Good afternoon, everyone. Thank you for coming. As mentioned, my name is Hugh McCam, and I'm here today to talk to you about the benefits of capturing test results information over time and how by combining this with visualization tools will help you have insights that will support your goals of having robust, reliable, and timely tests. Just before we get started, I work for Liberty IT. Together with our sister office in Dublin, we develop technical solutions for our parent company, Liberty Mutual. Liberty Mutual is a Fortune 100 insurance company with business and, as you can see, IT operations right around the world, including here in London, where I'm happy to be back after being an attendee at the 2012 conference, obviously this time as a presenter. So, on to the talk. There can be many things that we need and want from UI automation, but I'm just going to focus on a couple of attributes that I think we'd be interested in, particularly from a continuous integration perspective. The first of these is that we want our tests to be quick, to short execution times. Primarily, this is for fast feedback. In all development, we want the testing feedback loop to be as short as possible, and UI tests should be no different. If tests are too slow, people will not want to wait for the results to come back from them before continuing their development. And there may be a number of factors for slowness. Maybe the locator lookups, somebody's written some crazy XPath that means it's slow. Maybe the logic for interacting with a particular element means that your interaction is slow. If you have a drop-down that's really just a bunch of nested div elements. But also maybe the application itself is having performance issues. So if we were looking pointers on where issues might be occurring, we'd want to look at finding out, obviously, which tests are slow at a macro level, but perhaps maybe we'd also be interested in finding out which tests or which steps or methods would be slow as well. The second of these is that our tests should be deterministic. If tests are deterministic, we mean to say that when we run the same test a number of times, it should give us the same result each time. So as long as our automation is in sync with the application under test, a test failure should clearly indicate an issue in the application. But if it's non-deterministic, you can't say for sure if that's the case. Martin Fowler has a very nice blog from 2011 where he says that if you have non-deterministic tests, what happens is you end up shrugging your shoulders when these tests go red. And once you start ignoring a regression test failure, then that test is useless and you might as well throw it away. He goes on to say that flaky tests are also infectious because you can have a suite with, say, 100 tests in it and 10 of them are non-deterministic. What happens is because you are accustomed to having test failures that occur in otherwise healthy tests, people start to lose trust in those. And he says once that discipline is lost, a failure in the healthy tests will get ignored too. And at that point, you've lost the whole game, and you might as well get rid of all the tests. On the other hand, even if you keep up the discipline to actually look at all the test results, and I know a lot of people talk about that as an anti-pattern, and I tend to agree. But if you do keep up the discipline, then these tests start to become really, really expensive. More and more time is spent confirming your prior expectations, investigating these issues, rather than learning anything new. If all we're doing is confirming our prior expectations, we're not finding anything new, where testing actually comes from. So going back to the premise of the talk, how can we get a better handle on these flaky tests? First of all, we are interested in which tests are intermittently passing and failing. But we also might be interested in what are the common failures that are happening across tests. If we can find out what they are, particularly early on in the development of these tests, we can start to see the patterns and get them working. Alistair Scott had a nice talk at GTAC last year. His central thesis was that flaky tests were being used as a get-out-of-jail-free card. Basically, people were just accepting the failures and rerunning, as if it's always the test problem and not an application problem. He gives an example of talking about getting a build released, and about 5 of the 50 groups failed in the first run. So they reran the tests, they passed, they released. They didn't ask why they had failed, they just released out to production. And what they found was that people started complaining. They were having customers complaining about losing sessions and crashing. They went back, had a closer look, and what they found was an obscure caching bug. So because they hadn't questioned, they ended up releasing something into production that was really affecting the customers. He says that flaky tests are not useless. They're telling you something. You just need to work out what that something is. It could also be a testability problem. I used to joke with my manager that I would and I could bet my life on a test passing. Granted, this was on an application that was a little bit before all the JavaScript explosion. But that's because I knew all the hooks that to make the test robust. Knowing when the application was in the right ready state, perhaps making judicious use of JavaScript whenever WebDriver didn't quite do what I wanted it to do. But unfortunately, that's not the common experience. I'm not sure too many people would feel comfortable betting their life on a UI test passing. So Alistair suggests, for teams where you may have a specialist automation engineer versus developers developing the test automation, testers and test engineers should be embedded in the team, because what you need is the developers giving you the right hooks, the right testability in the application. Showing spinners for AJAX calls, having the right hooks to know when the magic async stuff is happening, so as that whenever you're developing these, you can hook into them and make your test more robust. So given all this, we might start to think about solutions for finding answers to these types of questions. We might start looking at something like a lheure. Whenever I saw a lheure at the 2014 Selenium conference, first of all, I think everybody thinks it is lovely, and it is lovely. But initially when I saw it, I thought that you'd be able to get information for multiple test runs. It shows information for a single run, which is really good and is really lovely. So you get the aggregation of top defects. So that idea of the common test failures. And then you get a summary for how long the particular test take. So that's pretty nice. It's starting to give us a partial answer, but as I said, it's on one single test run. The story really of where then I took this and where the story of actually coming up with a solution really started with this tweet from Noah Sussman last year. He talks about how he is sending individual test run results time and coverage to Graphite. Sarah in the lightning talks just now mentioned graphene. Was it graphene or graphite? Graphite. So these idea of DevOps tools being extended into other use cases. In this example, gathering unit test performance over time. In the thread, he goes on to say that he's using Jenkins, but Jenkins doesn't have a convenient way to visualize the information. And also it starts to eat up the disk space on the server. So there are two things I took from this. The first is the idea of capturing the information over time. How would that be able to help with those questions we had earlier? First question, which tests are slow? Because if we're capturing information over time, compare that to an individual test run, there's lots of things that can go wrong, particularly with UI automation. You can have network issues, or if you're running in the cloud, you may experience a denial of service attack that happened 4 weeks ago. But also, we can see which tests are non-deterministic because of the very fact that they can only pass and fail at different periods over time. Hard to see that just looking at an individual test run. The other aspect then was the tooling. So we use multiple CI tools, but tools like Jenkins, they do give you information over time, but it's at a much higher level. It's a build level, and it tends to be just the last 10 runs, whatever it might be. And then if you do want to store more, it does start to eat up a lot of space. So Graphite was mentioned for its ability to graph information over time and its low storage footprint. But I guess, sad to confess, I looked at Graphite. I was like, okay, that doesn't work with Windows. I want something with Windows. I also wanted something with open source. So I started looking into these types of tools that would provide some of that capabilities of Graphite. And this is an initial example dashboard of what I come up with. We'll talk about give you some idea of how we arrived at this, but this is just an example. Simple process flow. We run our tests using .NET and MS Test. Doesn't provide a convenient way to run tests concurrently. So we run the tests in threads and then gather the information back together into a particular type of file. This file normally is a JUnit results file, which then can be parsed by CI. But we also create this particular JSON file where we can post this information to Elastic. Elasticsearch is a tool for storing, searching, and analyzing structured or unstructured data. Free text, logs, database records. So this is typically something that's more used with application monitoring. As I said, this idea of DevOps. There are a number of other tools. Graphite is mentioned, Splunk, InfluxDB. But we're particularly interested in using it as a time series database. That idea, we store information, but we put a timestamp against it whenever we store it. So to get the information into Elasticsearch, there's this concept of mappings that you need to set up. Most of this information is readily available. If I give the example of using the JUnit results, duration, class name, the error message if there is one, whether it's passed or failed, that's all readily available. If you're running the tests in continuous integration, perhaps you have a variable that will be stored in the environment. And then lastly, you need the time that the test was ran. We currently, whenever we run this as a suite, we just give everything the same timestamp, just because of the way we aggregate our data. You could set it up to be more of a logging system, so that as every test runs, then it gets stored with its created time. I'm not sure how much difference that will matter. We're largely running all our suite of tests within 20 to 30 minutes. And this is just an example of how whenever you set this mapping, how you use Elasticsearch's REST API to set that up. So whenever you actually post the results, you specify the index that you want to store your results against. And then there's just one example for one test. This will be repeated for each test entry that you will have. Again, whenever you run these tests, you'll make a post call to store these group of test results. So going back to the process flow, we've ran our tests. We've aggregated the information in a way that's consumable by Elasticsearch. We've sent the data to Elasticsearch. And now, as I mentioned right at the start, we want to visualize this information. In this case, I'm using Kibana. Kibana works well with Elasticsearch. For people who are familiar with some of this tooling, it it all falls under what's known as the elk stack. So it also includes a tool called Logstash for getting logging information from applications. In this instance, we're not using that, but we are using Kibana with Elasticsearch. It just works seamlessly together, but you can use other tools to do the visualization. So to give you an idea of what it takes to create this visualization, given if we go with the assumption that we have already stored data within Elasticsearch and Kibana is listening to Elasticsearch, if we wanted to create a visualization, we have a number of options. The one that I'm going to do, just to give you a feel for it, is for a pie chart, where I'm going to try to replicate something like what a lheure gives you to group tests together that have the same failure. So you have the data, you create a new visualization, and it's just a big bucket. So we need to start splitting the bucket into slices. The first slice that we'll take is splitting the error messages into the buckets of the top occurring error messages. So we've selected the top 10. This is now the top 10 error messages by weight. So you're getting a feel for which error messages are occurring the most. You can then further split this, each of these buckets, into the tests that have that error message, which then looks like this. So in the inner segments, you have the error messages, and on the outer ring, the individual tests that have that are affected by that error message. This is all backed up by data. It's all in Elasticsearch, but we are getting a visualization, so you can hover over the pie chart, see a particular test, see the error message. I'll show an example later, but this isn't the only way to get at that information. So that's an example of trying to create a fairly simple visualization based on the data that we've been gathering. You can't quite see it, but this should say 30 days. So this is information over time. Again, it's not like a lheure, it's not an individual test run. It's going to be aggregating all runs together. So going back to the example chart, we have the failure reasons by test. The next one we'll look at is the top slowest tests. So this is the time in seconds up, and then we've got the top tests that have the top slowest tests in descending order. So we start to look at this and think let me just take a step back. This, and like the one at the bottom, this is 90th percentile. So again, going back to what we were talking about with cutting out the outliers, by taking the 90th percentile, those extreme variations that can sometimes happen, we can cut those out. So whenever I start to think about, slow tests, my particular view on UI automation is just having a really thin slice of functionality. So, what are your key business processes? Personally, I don't care about all the, are things displayed, what's on the screen. Can you execute the key business process? Because that, ultimately, to me, that's what the user's interested in. So we need to make sure that whenever we're writing our test, that that's where we're focusing on and not doing lots of interactions that I think start to slow up tests. Also, as was mentioned in Angie's talk yesterday, you may want to think about making can you do some of your data setup in using APIs? Because rarely, a lot of time you're spending your time navigating to a point and then doing something. So if you can cut that out, hopefully that would reduce the time. The next one is top failing tests. So I think I can't quite see that either. But you should be able to see the chart. So we've got some outliers. I don't tend to think of I think particularly when it comes to UI tests, I don't tend to think in terms of coverage, but more this idea of change indicators. So you want something that whenever it fails, we don't want the non-determinism. We want a really clear signal that something fails. This is an application issue. So if we are having lots of tests that are continuously failing, that signal-to-noise ratio is getting too high. And it makes it really hard to quickly determine if there's an issue. Whenever I first set this board up, I kind of went on a little bit of a rampage of deleting tests because I didn't feel that they were adding value. The noise that we were getting was far outweighing any kind of change indicator that we'd really be looking for. I'm in a fortunate position where I don't have to justify that too much. But still, you need to think about what's the value for what it's given you. I guess the other thing to mention in this, I believe that Dave Calwater made a reference this morning as well. At one point, I did set it up to automatically rerun. So, the test would run, and then if it failed, automatically rerun. I've actually turned that off because I think that, going back to what Alistair Scott was talking about, people get into the habit of accepting. I think it creates their own mindset that tests will fail. But I really think that you need to be hyper-focused and put a lot of work into it, but you can make these tests robust. Possibly, though, the most interesting graph is this one, step time versus number of times executed. So what that means is the green is showing the time, how long a particular step took. No, sorry, that's the wrong way around. The green is showing how many times a particular step executed, and then that sort of blue line is showing how long a step took, an individual execution of that step took. So this spike is, it's a little bit, it's not always going to be very clear, but this spike is for clicking next. And just the way we grab the data, click next is, there are lots of individual times that happens on different pages, but the way it's named, it appears as the same. So that's why we've got such a spike there. And then, as I said, the blue line is how long each one of those actually took. Sorry, not each, how long, again, the 90th percentile for those steps. So we just go up again to this. The other thing about this, there's a lot of intermingling of data here in the sense that we have some tests or some steps that are reflection of the automation in that how long it took to enter text into an element or how long it took to select from a dropdown. So those are automation times, so to speak. But the other times is if you're doing like a click, if you're doing a click next or doing a submit, the response time for the application to come back is going to be captured here. So kind of a little bit in together. It would be nice probably to separate that out. But to give you a feel for some of the things that we did find, a lot of these numbers, that I think that's about 60 seconds, that particular time, a lot of these were actually, in a sense, my fault. It's kind of the Spider-Man thing of with great power comes great responsibility. I created the ability to randomly select from dropdowns. And that's fine when there's 2 or 3 items in a dropdown, but once there's 60 or 100, then that gets really, really slow. So that's something we need to revise. As I mentioned, the server response times, I think that we do really need to look at filtering it out because I think we can get a sense of how long something's take. It's not going to be, it's a bit hazy, it's not necessarily terribly precise, but if we get a spike in that response time, it may be telling us something. I think the other main cause was just on the automation. So there were tables where we had to search for particular data, and the time taken to actually look through a table, use XPath or whatever, was contributing to some of these times. So I guess the question is, how do we get this? So earlier on, we just had the information from JUnit. This did not include this step information. We were already generating a custom HTML form or report with the results. This is already part of our solution. So it's meant to be a little red box, but what we did was basically just took a time difference between these timestamps, and that gave us a rough approximation of how long something was taking. But that was from the point of, finding the element, performing the interaction, and then everything's done before you do the next step. Because I did look at how we could get some of this information from elsewhere, the step time. I looked at using Sauce Labs information. It gives an awful lot of granular detail, but it has everything. So it has the time for whenever you first look it up, the time for checking if it's still in its position, the time for actually doing the interaction. And those are important, but I think we'll get a better sense of how long things are taking just by getting a less precise timestamp, but it's good enough for our uses. And also, if you're using a lheure's got really nice step reporting that, again, this information, you'll be able to extract it from. As I mentioned, everything is backed by data. So even through Kibana's UI, you can export the data into a CSV file and do some more analysis there if you need to. You can also use Elasticsearch's REST API to get directly at the data. So just to reinforce something, this is all aggregating over time. So by default, we have it here as 30 days, but you can splice it and slice it in whichever way you want. So it could be a particular iteration, or it could be the last week or the last day. Just whatever will give you that information that you desire. So I'll just start to wrap up. Going back, we want our test to be quick and non-deterministic. We can run our tests, get the results in the JSON file, post it into some sort of time series database, and then visualize that information. I think that one thing that's probably recommended is setting up the emailing functionality, which I believe exists, because that's nice storing all this, and you make pretty graphs. But someday you need people actually to go and do stuff, to actually react, and not think the job is just to write more tests. But keeping an eye on this. And you could also start to think about, going back to Noah's systems point, this is just the UI stuff, but you could bring in your API results, you could bring in your unit test results, and graph those as well, and see if there's any correlations to be drawn. We haven't went there as yet. So I think we're doing okay on time, so I'll just say thank you. Thank you for coming, and I'll take any questions.
It's a fairly small point, but people talk about flaky tests. I tend to prefer to think about flaky steps. Because if you have a flaky step, that's going to affect a lot of tests. Tests themselves, that's sort of an indication that the step is flaky, not the test is flaky.
Yeah, and that's certainly what I found. When I actually set this up, it's like, well, this is kind of good, but I think we need to go further. And that's what that last graph was really attempting to get at, yeah.
I want to add to the flaky point. So I don't think there is any such thing as flaky tests. It's a flaky design in the first place. If you don't design the test correctly, regardless of your implementation, it will still be flaky. But what you've done is a great way of trying to find these areas that have happened to help you then go and explore to see if there is any issues.
Yeah, I think that's a great point. I don't think that this isn't going to fix everything for you. You actually need to go and then do work. And I say that's, in a sense, the challenge that we now have. We've got nice information, but it actually takes, I think, a fair bit of skill and experience to really dive in and find out this information. I think there's a couple of people down there.
Hi, we're using Kibana at my company. How are you actually managing to configure the graphs as a visual output?
Say that again, sorry?
So we're using Kibana at my company.
Yeah.
How are you managing to actually configure the graphs to produce the visual output?
I did have the example of the pie chart. Go back up. Oops. Did want to do that. So there's the data for an individual test run. And that, when each time the suite of tests run, this all gets imported. And then, skip through. And then it said you get all these different types of visualizations. It's not, I didn't find it terribly intuitive. It takes a bit of practice. And it's also the challenge of what information you're trying to find, and then, yes, how do you visualize that? It is, I think, I found it fairly challenging, but there's a few people that have done something similar online, and I found that a pretty good resource.
Very approximately, how many man-hours would you say it took to go from like just having whatever Jenkins gave you to like setting up the mapping, Elasticsearch, and then stuff appearing in Kibana so we can start setting up graphs?
The short answer is I don't know. The longer answer, yeah, I mean, it's kind of on and off, depending on what I was doing. I said, the two phases. It was earlier on in the year, and then whenever I found out I was talking, this is an opportunity to put effort in again. I'd say in total, somewhere between 1 and 2 weeks. Because there's a lot to figure out. It was all new. I think for somebody who's more familiar, it wouldn't be as bad.
All right, that's all we've got for questions. Thank you very much, Hugh.